Hey, good morning, good afternoon, or good evening, whoever or wherever you may be. This is Mr. Randa, and I'm back. It's been a while since I've dropped one of these videos, so here's one more. This one is matrix number 11, using inverses to solve matrix equations. Let's get right into an example of what this exactly means. So here I have an equation. With this matrix, the 4, -2, -7, 2 matrix, times x. Remember, x stands for a matrix. In this case, right? I can't multiply this by some number to get that matrix. I'm multiplying this matrix by this matrix, whatever it is, and getting this -6, 12 matrix for my answer. So the question is, what the heck is this capital X matrix going to be? Well, first off, here's what I know. Bam. This one here is 2 by 2. This one on the other side is 2 by 1. So what must this matrix be to make that true? Well, think about it. The insides must match. This must be a 2 for the dimensions, right? And then look at my outside numbers. I have a 2 by 1, which means that this must be a 1. So this matrix here, this capital X, must be a 2 by 1. Like any other equation, I've got to get this X by itself, right? Get it isolated. I've got to somehow cancel away this matrix right here. If I can cancel this matrix out, then I'll have the solution all by itself. Okay, here's how this basically works. I'm going to step off for a second to a different screen to show you something, but this will make sense. So here's a general rule for how to do this. I have this matrix, or this equation here, right? A times x equals b. All three of these are matrices, okay? Here's what I do. Inverse. If I multiply the inverse of A to both sides, what basically happens is these two, inverse A and A, will basically cancel out, and you're just left with X, right? That matrix. So whatever, whoops, got the -1 there. Whatever this product is will be X. This right here, multiplying the inverse by the original matrix, just cancels it out, right? These two will multiply because they're inverses of each other back to the identity matrix, right? The 1, 0, 0, 1 matrix. So apply this, okay, back to the last problem. What I'm going to do then, I'm going to find the inverse of this matrix here. Okay, I'm going to call this matrix A. This is X, right? It's X. And this is matrix B, the one on the other side. So I'm going to find the inverse of A. This I'm just going to do with my calculator. So type in this matrix, find the inverse on your calculator. Here's what you get. So this matrix, the -1/3, -1/3, -7/6, -2/3, a lot of negatives, a lot of fractions. This is the inverse of A. So what I'm going to do then is multiply here and here by this inverse A matrix. Just like this. Observe. So I took the inverse of A, put it here in front of this matrix A, put the inverse of A in front of B. So I'm going to erase this now. So what basically just happened here, whoops, is that the inverse of A times A, so right here, these are going to cancel out. They're going to cancel out because they're inverses. They basically become the identity matrix. And I still have X, and it equals the product of these two matrices right here. So these two multiplied together get you the matrix -2, -1. This right here is your solution. This is your answer. How do you know that? Because this right here is the identity matrix. So that times anything is the same thing. So that's like saying 1 times something. So I can erase that now. That's basically been canceled out. So this is my answer. The missing matrix that goes right here is this 2 by 1 right there. Now one quick thing to add here. Make sure when you do this, you put the inverse matrix in front on both sides. Okay, I'm going to write that slow here. Well, I'm going to write it fast, talk about it slow. Put the inverse in front on both sides. Okay, I want somebody to tell me I said this in class on Wednesday. It'll make me happy, okay? put the inverse in front on both sides. With multiplication, don't forget order matters. So I have to do it this way. Put the inverse in front. Because this A inverse times B is different than B times inverse of A. So there we go. There's one example. Let's show one more. Here's my second example. So 25, 13, 13, 9, this 2 by 2 equals this 2 by 2, 7, negative 2, 3, negative 2, times some unknown matrix X. So I'm going to do the same thing here again. Find the inverse of this matrix and then multiply to both sides. So here we go. So first I rewrote the equation with some space because I'm going to insert the inverses in front, right? Inverses go in front. So I'm leaving space for that. Okay, so here is B, right? The equation, the matrix by itself. Here's A, that's multiplied by X. I need to find the inverse of A. So a little side note here. This one's A. I've got to find A's inverse. We're not going to do it by hand. We're going to do it with the calculator. Just so you know, A's inverse is this. So it's this 1/4, negative 1/4, 3/8, negative 7/8 matrix. So I'm going to multiply the inverse of A times each side, but I'm going to do that in front. Right? Inverses always go in front. I want to cancel out A and A's inverse. Back to the identity. So I'm going to do that here. And poof, I put the inverse in front of both matrices on both sides. These two cancel out to the identity, so it becomes just 1, 0, 0, 1 times X. I erase the inverse to save room. So that's the right side's all done. On the left side, these two matrices multiply with the calculator. That's all you got to do. Don't worry about doing this by hand. These are kind of complicated. I have big numbers and negative fractions. Just do it on your calculator. So when you multiply these two together, you get this 2 by 2, the 3, 1, negative 2, negative 3. This matrix is your answer because, again, identity matrix is just the same thing. That's basically, again, canceled out. So X, the missing matrix, is this one right here. This matrix can go right there. If you want to check them, go ahead and check them. I'm telling you they're fine and they're okay. One more thing to note. Sometimes you'll get an equation you can't solve. How do you know that? Well, here's how right here. If you ever get an equation with no inverse, as in you can't find it, then there's no solution. In other words, if you have a matrix and the determinant is 0, you cannot have the inverse, right? You can't do 1 over 0. So sometimes that will happen. Okay? I didn't show you an example of what happens here, but it might happen sometimes. If you get no inverse, there's no solution. We'll do more of that in class. Just want to show you the basics now. Okay? So go ahead and go to the next video. We do some encryption, where it gets hopefully kind of fun. We'll see how it goes. So, see you guys in a couple minutes. Adios.